but I'm not expecting you to do that. I want you to just use existing knowledge from the modules that you're doing. Okay, so don't worry, whenever it mentions Ruby or Rails, that's irrelevant to you. Okay? So that lecture is at 12 o'clock on the Monday. So what we're doing now is already there as an echo thing, which might be why some people have chosen not to come today. I don't know. Today we're looking at the design methods because you should all be getting to the point where you're moving away from the requirements that you have different feelings as teams as to how complete your requirements capture is, but you're still well over 50%, all of you, right? And even if you don't completely have all of your requirements captured, it's probably a good time to be thinking about the design. As we discussed last semester, agile development doesn't mean ignoring design. It's still very much an integral part of the process of software engineering. So you don't just jump straight from the requirements to the implementation. If you do that, you'll end up with a messy, badly done implementation. There are three key elements to this type of project design. There's the user interface, and most of you have already started thinking about that and seeing some mock-ups. And we've had some, those of you who've shown me mock-ups as a client have made me realise some things about the interface that I hadn't thought of. And hopefully you've got some useful feedback that's enhanced your requirements capture. Behind the scenes, you've got the database, or databases, where the information is stored. And that has to have some sort of design. And the third element to the design is the state changes. Okay? And that's what I'll spend most of today talking about. Okay, so the design process, the general principle is that the design is done in terms of models. Right? And when you're doing the models, you repeat the process of, first of all, constructing an initial model. Check that it has the required properties. That is, that A, it will work, do what you want it to do, and B, you can test that it works. Right? And those things aren't necessarily both going to be satisfied. Sometimes you can test it, but it doesn't do quite what you want. Other times, it'll probably do what you want, but you can't guarantee it through the testing. And ideally, you should be able to. If it doesn't satisfy those requirements, revise the model. And you keep repeating that process until you get a satisfactory model. And it probably means several iterations over the model. Okay, so you start off with essentially an approximation to the solution. And you look at it and revise it and come up with a better approximation until eventually you get the right answer. So, before I move on to this one, the slide that's missing there is the user interface design. So your user interface should be designed in terms of, first of all, mock-ups. And those mock-ups, probably in the very early stages, will be hand-drawn on a piece of paper, say, talking to your friends, saying, I think it should look like this, and you draw it in a box here and a box there, and in this box you've got that and that sort of thing. And then you move to a graphical, computer-generated representation of it. And eventually, you'll move to a prototype, where you're actually implementing the HTML and the CSS that creates a web page for you, but you don't have any of the functionality behind the forms. Right? So it looks like a functioning web page, but if somebody actually types things into the boxes, it doesn't do anything with that information yet. Right? Now, when you're moving from, you're starting with mock-ups and then moving to prototypes, it's a good idea to do as much with your mock-ups. Guys, it's quite distracting. I can see other people looking over at you, and I can hear you as well. When you are doing your mock-ups, it is basically just drawing, right? There's nothing more to it than drawing. It might be drawing in an electronic form, or it might be drawing on paper, but it is very much a simple thing to do. That means it's relatively cheap to fix afterwards, right? Because it's just a drawing that you're changing. You want to be fairly confident that you're pretty close to what you're going to get to before you start doing your prototyping. Because once you've started doing your prototyping, you've started writing code. Yes, it's only HTML and CSS, but changing HTML and CSS is a lot more costly than moving a box around on a screen, right? So until you are sure that you've got the boxes in the right places and you've got the basic look and feel that you want, don't waste time writing HTML and CSS, okay? Or if you want to, I guess you could do the HTML, because HTML is about the content and the CSS is about the style. And CSS, you probably come to realize already, is quite difficult to get right. Okay, so you can spend a lot of time editing your CSS to get it to look just like what you've got in your head. And then if you show it to your client and they go, actually that's not what I want, it's all wasted effort, that effort you've put into getting it to look like what's in your head, if what's in your head is not what the client wants. Okay? So instead, take what's in your head and draw a picture of it and say, is this what you want? And when the client says yes, then spend the time getting the CSS right to make it look like that. Okay? So it's about the way of doing it that's going to cost you the least. Right. So database design, and this is a recap from last semester, so I'll go through it really quickly. So modeling a database, we use entity relationship diagrams. Okay, they're basically predecessors of UML class diagrams. And the entities represent classes, so your database tables basically, and the relationships represent associations, so the foreign keys in the databases that link your databases. You have a limited choice of multiplicities. You have one or many, optional or compulsory. And when you're constructing them, you start with a class diagram for your database table. So you use UML notation for this. You analyze the multiplicities. And then when you want to check it, you check that it supports all of your user stories. Okay? So if you have anything that's mentioned in your user stories and you don't have a place for it in your databases, there's something wrong. It also, in order to check it, you need a model of the code, because you have to know how it's going to process the data and whether you're going to be able to update it or retrieve it in the way that you want in your code. So you can't complete the checking of your database design until you know what the state transitions of your code are going to be. You want to minimize data dependency in your databases. Now all of these slides are just ones that I've taken from last semester's notes without putting the full set in there, so you can go back and get more detail by going back to those slides. So your design goals are, first of all, remove duplicated data and redundant paths. You want to get rid of duplicated data because you don't want a situation where you update it in one place and it doesn't get updated in the other. You're representing each thing only once. Redundant paths is just a space efficiency matter, and for the type, this particular project, you're probably not so concerned about space, but still it's a good principle, right? You want to optimize your table structure to allow for independent insertion, update and deletion of data items. So you don't want cascading effects where updating one thing causes changes to other things and so on. And the minimization technique that we're using is, first of all, merging tables that are in a one-to-one relationship so that we don't have to do joins unnecessarily. Linking tables that are in a one-to-many relationship. And introduce new linker tables to encapsulate many-to-many relationships. Find redundant search paths navigating to the same sets of rows and delete the shorter path. The reason we delete the shorter path rather than the longer path is that if we delete the longer path, we're going to lose links that are in that path. So we had examples in the slides last semester about what these specific things were. Okay, so go back to those slides for the details on this. Right, now I said, in order to check, you are going to need to know what the system behaviour is. And what we do is we use state models to represent behaviour, where an object has usually a small number of states. We're not worrying about huge numbers. The inputs can cause the state to change and possibly outputs to be generated. Or the outputs themselves could correspond to the state. So you think of inputs into a particular state, makes a transition to a new state. Yeah. State transitions depend upon what the current state is and the input values. Okay. So if we want to represent state machine models, we can start with the best way, I think, is with a state machine diagram where we have boxes for the states, lines for the transitions, which are labelled with the inputs and outputs. So here's a really simple example of a combination toaster oven, right? So it can be a state where it's heating, and within that state it can be either toasting or baking. But if the door is open, then it can't be in the heating state. It turns off the heating when you open the door, right? So that's an example of a state diagram, a UML state diagram. Alternatively, you can use a transition table. And if you're using a transition table, you can just have a row for each state and for each input, and then say which state it's going to transition to given those inputs from that state. So that would look something like this in a really simple case, right? So if you're in state A and x is equal to 0, we go to state B, but if x is equal to 1, we go to state A, and it gives that output as well. Okay, so this is a really simple case of a state transition table. And I stress really simple because as soon as they get beyond simple, they start getting very complex, the tables. And I don't think they're particularly easy to understand. I think we're much better off using a diagram than a table. If you really want to, it is an acceptable way of capturing state transitions. Now, that's state machine models in the UML sense. Sometimes you want to move beyond the simple case of just inputs going to a particular state, producing some output and possibly a new state. What we want to do is to describe the variables and the functions that are applied to variables as they do the transition. Okay? And that's particularly true for the types of state changes that you would have. For example, when you transition between web pages in your application. So, for example, when a judge enters the scores and presses submit, there's probably a whole lot of functioning that goes on behind the scenes that causes the databases not just those things to be stored, but a partial score to be calculated. Yeah? So you'll see some of the output in that you will transition to a new screen, probably prompting for another competitor or something like that. But there's a lot that goes on behind the scenes that doesn't appear in the new state that appears visually, right? So, and we don't want to describe every detail of those. So, for example, if on a particular challenge there's a thing to tick if they've touched a wall or something like that, you wouldn't want one state transition to say no wall was touched and another one to say a wall was touched once and another one to say a wall was touched twice. You wouldn't go into that level of detail in your state machine diagram. Instead, you would just say that there is a function going on which does some calculation based upon the inputs that were put on this web page, which produces some outputs in the database, And the new state that we end up in is always this particular one. Or you might have two different possible states. So for example, if the judge pressed submit and they hadn't filled in the box that they needed to, it might pop up a message saying you need to complete this item. Whereas if they had filled everything in, it just goes to the new page. So there's an example of where you could have two possible different resulting states. So each transition that you have changes variables. Expressed, it does say here in terms of mathematical functions, but it could just be in terms of, some sort of processing that happens in your code, whether it's a mathematical function or not. But the inputs and all values of those variables will be the inputs to the function or the processing that happens. And there are lots of different formalisms that are used for extended state machines. I've listed some of them here, and it's not meant to be an extensive list. So we've got state charts, abstract state machines, X machines, and extended exit machines, or XXMs. This last one particularly was designed here at the university about 15 years ago, specifically about web page design. Right? But I don't think it's necessary for you to go into the detail of learning any one of these specific tools. What I would say is just use standard UML state machine diagrams that change the transitions, which are usually just dependent on the value of one variable, to express the detailed change that's happening. Okay? So instead of saying x equals 0, x equals 1, put in a more complex expression than that. So why do we worry about states? Well, primarily because you need to worry about them when you're thinking about testing. It's not enough to test each individual view, okay, because you need to think about the transitions between the views, because there is probably quite a bit of processing that goes on as you do that transition, and you want to make sure that the correct processing has happened when you get to the new view. You need to ensure that your test cases exercise all of the possible paths. So that's not just testing the transition from one state to another state, but it's here I've started using the system, and over here I've stopped using the system, and I could go through this arc to get here, or I could go through this arc to get here, or I could do that, or and you've got to be able to say that every one of those possible routes from start to end performs correctly. And the best way to do it is a visualization which says these are all the paths that I need to test, and then build a test case that will test every single one of those paths. Okay? And you might start by doing a test case that just tests the transition from this state to the very next state. And then another one that tests from this state to the very next state. But you also need to check the flow through from start to end. Okay, so having that clear picture is going to make your test design easier. In terms of documenting your design process, yes, you're using an agile approach, and agile emphasizes the sort of development and production stuff more than formal documentation, but that doesn't mean that you throw documentation away entirely, right? So keep copies of your designs in your team or your group shared folder, and keep a history of the changes. So one way of doing that is to put the date in the file name. When we're marking it, we're going to be looking for evidence of your design, all three different elements of it. The user interface in the form of mock-ups, those are just screenshots of things, or if you've done it by hand, scan it or take a photo of it and put a copy in your folder. your database design, and your behaviour design. Now the last point is that agile development should involve refactoring. What does that mean? This is why you have to do the practice this semester, even though we talked about the theory last semester, because it's all very well to talk about these things, but until you actually do them, they don't sink in. What refactoring is that redesign of the structure of things to make it better. Okay? So you might start off, well not start off, but you say you've done your design and you think you've got good design for all three of these things, and you start implementing. And a week down the track, or 2 weeks down the track, you think about it again, given the implementation that you've done, and you go, actually, I think it would be more useful to have another table in our database, something like that. And so your design changes. That's what refactoring is. It's about adjusting the design that you have to get a better ultimate product. Okay? So when you're refactoring, keep track of the design changes and put the evidence there for assessment at the end. Okay, so all of this comes into this point in your assessment here. That the heart of it we're looking at, this is the team marks coming from me as a staff member about your management. You've got your team organisation, which is evidenced by the minutes that you're keeping in your shared drive that you're going to submit. Your progress with the implementation, so you haven't started doing that yet, but you will do, and that's what, after week 5, the Wednesday afternoon sessions will shift from Ian's meetings to me as a staff member checking on your progress and seeing how that's going. And your key documents, so that's what we've been talking about today, well, and last week. They're only worth 5% of your overall mark. Okay? So they're going to be marked out of 5, 0 if you haven't done any at all, 1 if you've put some documents in there that they're inadequate, 2 if they're there but pretty dodgy, or if you've missed some of your documents. Okay? So if you don't have all of them there, you won't get more than 2. 3 for a complete set of documents that are only a borderline standard. 4 for a complete set of documents with perhaps some flaws. 5 for an outstanding effort. Okay. Any other questions about the rest of the marks in this area?
Shouldn't the diagrams be included in the requirements document or the plan, or just
Sorry, the diagrams.
Yeah.
Normally you wouldn't put the diagrams into the client document, no. Okay. But I'll get you to, on the next slide, there's something I will talk about in that respect. Okay. Yeah, so testing you need to be thinking about sooner rather than later. Basically, as soon as you start doing implementation, possibly even before you start doing implementation, start thinking about testing. But you will need to have done your design, because testing is about your paths to the system. The quality assurance, basically, after week 10, whatever you've done at that stage, in terms of your code, is given to another team. So we'll do swaps. And that team will have to do quality assurance of your code and identify any problems with it and write a report. Okay, so it's up to how well you judge other people's code. Yeah? So when you're writing your code, be bear in mind that it's not just your team members who are going to be reading it. If English is not your first language, even if everybody else in your team speaks the same first language, you need to write any comments, any variable names, or anything like that in English, because the people who are doing the quality assurance may not speak your language, right? So that is something that happens in our undergraduate thing occasionally, where I get a team of people whose first language is all, I don't know, Hindu or all Chinese or something, Mandarin, and they put comments in that language. That is problematic when they come to me and they want help with debugging things, but it's certainly problematic when it comes to another team doing quality assurance. Poster session, it's not a poster in terms of a printed poster. It'll be the same as you have to do for your dissertation project. You do a presentation on a computer. You will have two computers side by side. One of them will run your demo. The other one will have a very small number, probably 5 slides, highlighting the key points about your solution to the project and anything that you think is of interest that you want to present. Okay. This table, this is the marks from me as a client. No? And I've had a number of questions from the undergraduates about the documentation point here. So you do need to provide a user manual in some form, and nobody's asked me about what form yet. So in terms of that is something you need to ask me as a client about, how I want that to be. And the installation guide / maintenance document, it's in there vaguely because for the undergraduates they've got a whole lot of different clients and different people have different ideas. For me, what I am developing this software for, or getting to develop this software for, is something that we can take and extend and adapt to our next year's competition. So I need enough information in that document that I can give it to another coder who hasn't been involved in the early stages of development, and they should be able to take it over. So that's another reason for putting everything in English. Right? But in this document, this is where I would expect to see your design diagrams, so that that person can have an understanding of the overall view of the system and understand your rationale for the decisions that you made and that sort of thing, about why it's been implemented the way it has, because that should be reflected in the design documents. Okay. The reason that it could be different for different clients is, so for our undergraduate ones, some of the clients are asking for this to be developed as a prototype of a system that could be done as a demonstrator to say, give us a lot of money so that we can build something that's a lot bigger and better than this. And they're not going to use the existing code that's there. They just wanted to be able to show it to the funding body to say, this is the sort of thing that we would like on a much larger scale. So that document for the undergraduates can change quite substantially. For the ones who are doing it as a prototype, they need to make it like a sales pitch type document for the funding body to say, this is why you should do this. Okay. Both of those things should go into your requirements document. They are part of me, the client's requirements. Okay. Non-functional requirements. Okay. You might find there are other non-functional requirements which don't typically get captured in user stories. So bear that in mind.
Excuse me.
Yes?
Do we need to do installation guide?
No. So, for the undergraduate projects, it's very mixed. Some of them are writing up for internal clients within the university, in which case it's not a full guide. It's basically they say you need to go to Kix and they will install it for you. For the few that are doing it for clients outside the university, they basically have to say you need a system that supports Ruby on Rails for their particular thing, because that's a very specific technology that not all ISPs will support. You need to check with me if you're using something other than very standard things like Java or JavaScript or various, MySQL or something like that. All of those things are standard things that I'm absolutely confident that we can support. But if you want to do something that is unusual, check that we're going to be able to host it on our system in Cambridge. Okay. User manuals can be as a form of a written user manual, like a book, but I would expect it not to be printed, just in an electronic form. Or it could be inbuilt to the system, as it is in an online help type system. Okay. If it's inbuilt into the system, you could argue that actually it is a functional requirement rather than a non-functional requirement, but you get the idea. User manuals, there might be different requirements for different types of users. Okay. For example, I have taught you, I think all of the groups now, about the fact that when the volunteer judges use the system, I don't want to need a user manual. It should be just so intuitive that they can just use it. Okay, they're going to be computer literate people, so they know how to use computer interfaces, but they shouldn't have to look anything up to work out what they're doing. They should be able to just log in and see, obviously, as soon as they get to their station, this is what I'm meant to be doing. Okay, so the other things that are here. Final demonstration, that's basically your poster session. You get double points on that because for the undergraduates, they get a staff member judging it and a client judging it. Because I'm taking both roles, you get 5 points from me as a staff member and 5 points from me as a client. Okay, realistically, I don't think there's ever any difference between the way staff members and clients judge those presentations for the undergraduates. So it's not really going to be a disadvantage to you. Communication throughout semester, that's about how you've been communicating to me as a client during our meetings, and if you have been emailing me as a client, which nobody has yet, but you might do down the track, about doing it professionally, being prepared, being polite, that sort of thing. District system, ease of use and understandability. Okay. Completeness. So have you actually done all the things you were meant to do? Innovation. So interestingly, the 4 teams are coming up with quite different solutions. Doesn't necessarily make one of them better than the other at this stage. But in the final product, I might decide that that actually that thing that team thought about adding above and beyond what I thought of in the first place was the deciding factor kind of thing. Robustness. Basically, I don't want it to crash. Really don't want it to crash. And then happiness, the overall impression of the system. Okay, and I think I'll probably, if I can, get my colleagues down in Cambridge to judge on that point. Any other questions about that particular slide? Okay, so the eagle line between you will have noticed that these 2 slides don't add up to 100 points. Right? You've got here 50 points, here 35 points. Yes, that's what it's meant to be. So these are the team marks, these 2 slides. But all of you as a team will by default get the same unless you decide as a team that somebody has not been working as much as the other. And if you look on MOL, there's an explanation of how that's calculated. You all submit individually what you think of each other's performance, including your own contribution towards it, and then that gets weighted and then that factor gets applied. Right? I'm hoping that you will all be comfortable that you've all made equal contribution. Where equal doesn't mean you've all done exactly the same thing. One person might do more in one bit and another person does more in another bit. So it's about balancing. Right, the remaining 15% is you individually, you submit a report. Okay. Again, it's a reflective report, and there's more specific details about what's meant to be in it on MOL. It's more specifically targeted than it was last semester. It's the same sort of idea. You're being asked more specific questions, though. Okay, it's not just reflection. It's very it's on MOL. Okay. So in summary, your design process is, first of all, design the look using mock-ups and prototypes, design the data, the database tables to store it, plus any internal data structures for the views. Okay, so you've got your database, your back end, where all your data is being stored, but you might have some transitory variables that are used within a particular view that never get stored into the database, they're just used while you're processing that particular view. So there's other data other than the databases. And then the processing, the paths through the application, and check that your design is sufficient, that it supports all of the processing functions. Finally, once you've finished your design, then you can derive your test cases. Okay. So that's the end of the material for today. I know it's a bit shorter than the full hour. Any questions? Yep.
For example, if we make any update or a change on the design or any other pieces, should we keep copies for the updated version and the old version?
Yes. Yeah. If you've already done changes and you haven't kept the old version, so be it. Okay. But in general, yes, I am expecting your design to change as time progresses, and I would like to see evidence of that evolution of design. Okay. Sorry. Code documentation, yeah, as in inline documentation, yes. Any code you write should always have inline documentation. Particularly in a case like this where it's going to be taken, you know that it's going to be taken over by another developer. Or at least, I can't guarantee that your particular team's one will be taken over or that any one individual team's one will be taken over. We might use elements of different ones and sort of refactor it and merge the bits we like of this one and the bits we like of that one, that kind of thing. But we're certainly planning to reuse at least some of your code. And we want whoever's taking over the code to be able to understand it. Yep.
Regarding timesheets, are we supposed to explain right now?
Yes.
Is it possible to enter the past entries?
Yes, you could. Yeah. Ideally, you would keep them up to date at least on a weekly basis. But if you've missed things, a couple of weeks down the line, you say, "Oh, I forgot to record that." You can do that. You can add it. Okay? So yeah. But yeah, there should be an accurate representation. And remember, it's not just the time you spend together as a team. Some of you will be going away individually and learning about particular technologies. That's research. You record it as research. And that counts towards your time for this module. Because most of your time in this module is outside the classroom. Okay, it's meant to be 150 hours per person, and we've got very little classroom time. Okay? Any other questions?
Excuse me. Why do we use machine state, not, for example, activity diagram or something else?
Activity diagrams are usually a finer level of, so if you had within your state machine diagrams, you had one transition that was particularly complex, or that there were sort of many different possible transitions, you might choose to look at that particular one in more detail, and you would use an activity diagram for that. But generally the activity diagram is going to be at a much finer level of detail than a state transition diagram. Yeah. So it might be in terms of the actual users inputting different things in different parts of the web page and describing what happens in those different things, rather than the transitions from one web page to another.
You say if we change our design, we have to include it in the document, right? So
okay. So in terms of assessment, I want to see your history of design. In terms of the document for the client, it's only the final design that should go into that document, because that's what the future developers are going to be interested in, not the path you use to get to wherever you are, but what your actual state is at the moment.
Okay, so the change of design means when we start implementation and we change the design, or if in the client meeting, if we show the client some data and they told us I need to change something, these things or
both. Both. Okay, so there was one group last week, and I can't remember which one of you it was, who showed me a mock-up, and I said, actually no, I don't want it like that. I really would like this information instead. So that's going to be quite, I'm expecting to see, if I see another mock-up this week, it might happen next week, but whenever I see a new mock-up, I'm expecting to see something that looks very different. And that should be saved in your team directory for submission. But then you might have other things, and you're unlikely to see, once you start doing the implementation, major interface changes like that. But there'll be other design changes that happen, probably due to code refactoring, which might mean database design changes, or it might mean something changing about the transitions on this between states or something like that.
Should we require the data changes and consider it implemented?
I think it's enough to just timestamp the documents if you're going to store them as, so just put the date in the file name. Say this is the mock-up as of whatever date, something like that. Or you can have a separate document, that would be fine as well. But it's probably easiest just to put it in the file name. Any other questions? So you should take note of the answers to these questions, because this is one thing that won't be in the recording from the earlier one. Okay.
So in the client meeting this week, we have to show the client the requirements
if you think your requirements document is ready, then I'm very happy to look at it this week. You don't have to have it for me until next week, at which point I won't sign it off then and there, but I'll take it away and I'll give it back to you in a couple of days, kind of thing. But yeah, I'm expecting to be getting towards the finalisation of requirements. It's really, you are all at such different stages. I could tell from last week's meeting that you've advanced in very different ways. So it's about what's right, what feels right for your team. If you think you're ready to have your requirements signed off, by all means present them to me. If you think you need to have more clarifications or more details about particular aspects of the system, spend the meeting doing that. Okay? If you don't want to meet me as a client next week, if you give me the requirements this week and I say, yep, all fine, and I sign it off, and I see a prototype and I say, yeah, that's perfect, and if that happens, that's fine as well. Okay? It's about, but generally we say that spend the first 5 weeks gathering requirements and then move on to the design and testing and development. But if you're ready to move on earlier, then you can. Okay. It's more that those milestones, they're guidelines, and if you get there early, fine. If you get there, if you said you were there in week 2, I would have said to you, no, you're not. Okay. And I have had some of my undergraduate teams who've said that. I think we're ready to start coding. I said, show me your design. you haven't done design. Okay, so that happens. But we put the milestones in as guidelines. And some teams, I don't know, there might be some of you who aren't ready for your requirements to be signed off at week 5. If that's the case, we won't have that formal meeting in week 6 anyway. You'll need to get in touch with me outside of last time to arrange a meeting. But you can do it a week later if it's what your team needs. If you do it 2 weeks later, I'll be saying, I really think you need to get a move on, and you know. But that's the point, is that they're guidelines about where you should be up to in your progress. Okay? Anything else? Okay, so next week is the last one of these formal classes, which corresponds with the last week that you meet formally as a client on the Wednesday. So then after that, it would be just me as a staff member spending half an hour with you in the same, well, not in the same way as I have with the client, but a half-hour window where I'm going to be checking on your progress and just monitoring your team in general. Then you can get clarification on anything that you need to at any time. You don't have to wait till Wednesday to do that. You can always email me. And yeah, it's basically it's up to you, right? I'm well aware of the difficulties of the fact that you're doing your web and internet technology module at the same time as you're doing this, and so you don't have the full swag of technologies that you need to do your implementation. But I think you should by now have enough in that module that you can at least do the front end, right? And I'm told that in a couple of weeks' time you'll be doing the database stuff in that module. So by the time your front end is finished, you should well and truly have the knowledge to do the back end part of it as well. Okay? And you can certainly do the database design without knowing exactly how you're going to do the implementation. And some of you in time before university have done database stuff before and you already know what you want to do for it, and that's fine as well. You are very mixed abilities in terms of your backgrounds, and you can take advantage of that. Okay? All right, I'll see you on Wednesday then.